Next up, we have Veerkumar Patil, who will be giving a talk titled Beyond the Layers, Testing Microservices and Nanoservices Effectively. Veerkumar is the Principal Software Quality Engineer at Red Hat. Please give a round of applause to Veerkumar.
So, good afternoon, everyone. It's great to be here today at FOSSASIA 2025. This is my first international conference, so a bit nervous, but still I'll try to deliver my best, okay? So today I'm here to speak about something that's transformed the way we build, test microservices and nanoservices. As software systems evolve, monolithics are become broken down into smaller, more modular, and manageable components. While this flexibility increased the scalability, it also introduces some challenges, especially when it comes to testing. And that's exactly what we are going to see, and we are going to explore in today's talk, Beyond the Layers, Testing Microservices and Nanoservices Effectively. So, before actually jumping onto the topic, let me quickly introduce myself. So my name is Veerkumar Patil, Principal Software Quality Engineer at Red Hat, an open source contributor who believes that you have to give to community to grow in your career. I'm also a mentor in different testing communities, actively involved with Test Tribe, which is a Pune-based, testing community where I contribute more. I'm also a YouTube content creator, sharing insights and some tutorials around testing. Apart from that, with Red Hat, I got an opportunity to review a book on the Cypress, which got published in 2023 around ultimate web automation testing with Cypress. And I proudly test websites, so I'm a proud tester. Why I say that? Because I feel quality is a prime importance when you wanted to build a product. Okay, and I know I just found bugs whatever I touch, I found bugs. That's why I called. Even today, before coming onto the stage, there was an issue with my talks, times. So previous talk was of 25 minutes and mine was 15 minutes. And the previous talk was starting around 11:45 and this was at 12. So it was a kind of small bug onto the application that got caught thanks to one of my friend who called me yesterday. So that's why I called it a proud tester. So without further ado, let's get started. So my talk is mostly around some questions, and those questions we'll try to answer over the period of time. So, okay, so first question is, how do monolith microservices and nanoservices differ in architecture and scalability? So let's try to understand this particular thing first. Okay, so in order to explain this, right? The technology has been evolved over 2 decades, where a single monolith architecture will consist of a tightly coupled system where UI, business, data access layer, it's been, kind of unified into a single code base, which are tightly coupled. It has a simplicity. It has a simplicity. It can be simple deployment, but it also had some cons. Like these particular architecture is difficult to scale. Okay, when it comes to deployment, these applications are pretty slow in deployment. And imagine there is a bug in the system and that can take your entire application down. Okay, so these are the cons, that has, taken over with advancements in the technology where the microservices architecture comes into picture. So when it comes to microservices, right, so how it differs from the traditional monolith architecture. So basically, you break down the entire application into small independent services, and each service is responsible for a specific business function, which are easy to scale, independent deployment, and you can isolate it from one another, still able to interact with one another. So with this, even though it provides advantages, it comes with some complexities as well. The complexities around infrastructure, high inter-service communication, because in order to interact with your entire application, you have to be, interact with different services. For example, you can see on the left, microservice is interacting with another microservice, and another microservice is actually interacting with your database. So with that, let's jump onto the nanoservice part itself. So nanoservice is, I'll give you an example, real world example, how nanoservices differ from the microservices, okay? So imagine a website where you can see the green box over there, and inside that you see orange boxes, different orange boxes. Those orange boxes are talking with different nanoservices to get that particular data. For example, you're generating headline over there, or you might wanted to have some data from your weather information, or you wanted to update a match score. Like for example, there are football matches, or there are some cricket matches going on. That particular data can come from a nano service and will be available on the page. Another example that Red Hat is actively using is on their homepage. So these components are built with the data coming from the nano services. So next question is, why is testing microservices and nano services different from the monolith application? So I'll quickly change the slides, okay? So monolith applications are tested as a whole, while the microservices and nano services are independent, distributed, and loosely coupled. Challenges arises due to dependencies, and challenges arises due to inconsistencies across the data. Now let's go on how you can better test these things. What are the different test strategies that you can apply for testing microservices? Okay, so I'll quickly jump onto the slide. So these are the traditional testing strategies that you can apply for any of the microservices, like unit testing, integration testing, contract testing, E2E testing, load testing, and resilience testing. We'll jump on each of the things once I explain the stuff, okay? So how you test API interaction between microservices, okay? So for example, you have a microservice application for an e-commerce website where you have a user service, you have a login service, you have a payment service, and you have a actual booking service. So in order to test this particular interaction, you can always look for the unit testing where there are price calculation involved. You have an interaction between the booking service and the payment service. You can test out that particular integration with the integration testing. You might have an end-to-end test flow with your web UI, a web application, or a mobile application. So for that, you can use different tools as well. For unit testing, you may use JUnit if you're using Java-based microservices design. If you are using for example, if you're using a JavaScript-based tests, then you can use Jest for writing your unit test cases. When it comes to front-end stuffs, right, you can always rely on the end-to-end test for the tools like Cypress, Playwright, which allow you to do that testing, front-end end-to-end testing. Then how we can perform load and performance testing on microservices, okay? So this is one of the critical aspect of a testing where you wanted to test out your app is performing very well, or your microservice is performing very well under stress. So for that, you can use tools like Gatling, which allows you to, which allows basically you to do a performance testing. There is a tool called as Locust, and apart from that, you can use a tool called as JMeter, which allows you to perform the load testing. How do we implement chaos engineering for your microservices? So basically, this is kind of resilience testing where you wanted to ensure that your application behaves properly in case of major failures. It should handle those kinds of failure in graceful manner. For example, your payment service is not available. Then in that case, how your front end should, react when these kinds of situation happens. So you have to be, test those things when it comes to resilience testing or, performing the chaos engineering around your services. What are the best practices for security testing in microservices? Okay, so with the advent of technology, the security testing is a important aspect when it comes to microservices. You have to rely on ensuring authorization and authentication of your services has been implemented properly. You're not, over sending the data or over exploiting your data whenever the response is sent to the, front end applications. Lastly, how does CI/CD help in testing microservices and nanoservices? So, everybody is talking about continuous integration and continuous testing, where, you have to make sure that, testing in CI is been, primary focus when it comes to QA. They have to make sure that whenever a push has been made or MR has been created for a service, it has go through the testing steps, and that should be of a prime importance. A key takeaway is like if you wanted to, build a quality service, right? You have to combine your integration testing, contract testing, performance testing, continuously monitor your service performance, use mocking and CI/CD pipeline enhancements. I'll not take 2 minutes. A small bug, so these are the key takeaways for a QA. A small bug in one service can break everything, so test wisely. If you are a developer, clear code, clear test makes strong system. So make sure that you write a clear code and unit test cases. And if you are a business leader, please make sure that quality isn't an act, it's a habit. Well-tested microservices means fewer surprises. So make sure that whenever you are delivering a product, give some time to testers to test the applications. With that, I am close to my slides. So this is one of the collection where you can find the different resources available for testing. So Postman has very good collection around how you can perform integration testing, contract testing, async operations, and all those. Lastly, I just wanted to share my coordinates where you can connect with me, my GitHub, LinkedIn, YouTube, and thank you everyone for listening me.